Welcome back. Let's look at part 2 of the problems that we're solving in chapter 10, and this is the in-chapter example of a fast burger restaurant. Here's the problem description from the chapter, and from that we can see we have an hourly demand of 100 customers, and the average customer consumes this 4 ounces of hamburger, 4 ounces french fries, 12 ounces soft drink. Management's trying to decide the number of resources they need, how many grills, deep fryers, and soft drink spouts. And so if you take these per customer values times 100 customers, that gives us these values for the peak hourly demand in ounces for each of these 3 products. So let's take the grill first. A grill cooks 48 ounces every 10 minutes. So if you're going to do 48 ounces in 10 minutes, then it means that you're going to do 6 times that, or 288 ounces in an hour. Okay, so for the number of grills, we need 400 ounces per hour. Each one can do 288 ounces an hour, and so that will give us 1.39 grills that are needed. Management decides to purchase 2 grills. What will the utilization be then of those 2 grills? Well, utilization is resources used over resources available. Used would be 1.39, available would be 2, and that would give us about a 69.5% utilization. How about the french fries? Need 400 ounces. French fries 2 pounds in 6 minutes, or 20 pounds per hour. We need it in terms of ounces per hour. So 20 pounds per hour would be 320 ounces per hour. Again, we need 400 divided by the 320. That would give us 1.25 of the fryers needed. Management decides to go ahead and get 2, and so that utilization would be 1.25 over 2. And so you can see again the utilization is fairly low. It's about 62.5%. 1,200 ounces per hour of the drink is what the capacity of one machine is. We need 1,200, so we'd actually have 1,200 divided by 1,200, or 1, indicating that we would need 1 of these soft drink spouts, and that would be just a little bit too tight there. Need 1,200. 1 could provide 1,200. Management decides to provide 2, and that would be a 50% utilization. So the last thing is, if you had a peak demand of 100, if a person could do 15 per hour, you want a utilization rate for the job of 85%, then how many would we need to staff? Then utilization is demand rate over service rate times the number of servers. So 0.85 is 100 per hour over 15 per hour times the number of servers. Solve for the number of servers, and we would get 7.8, round up to 8. 8 would be the number of servers that we would need for this. Thanks.